y'all, welcome to Miss Clarke's chemistry class. We've been talking about classifying matter. In this video, we're going to talk about the types of mixtures. There's two types of mixtures. We've got homogeneous mixtures and heterogeneous mixtures. Now, I hope those prefixes seem familiar to you. In biology, we talked about homozygous and heterozygous. Now we're talking about homogeneous, heterogeneous, same prefixes. Homo still means same, hetero still means different. Now let's look how that applies to mixtures. Homogeneous mixture has the same proportions of its component. So here's an example of a homogeneous mixture. In fact, it's a solution. We took salt, NaCl, and water, H2O, and mixed it together. Now, if I were to take a drink of this, I'm not going to, but if I were, I wouldn't say, let me just take a drink of the top because that's where it's the least saltiest. No, the composition is the same throughout. It doesn't matter where I take my sip from, it's going to taste salty. Solutions are also homogeneous mixtures. We use so many solutions in chemistry, and every time we use a solution, it's a homogeneous mixture. Alloys are also homogeneous mixtures. Sterling silver is an example of a homogeneous mixture, an alloy. I have an example of silver. Sterling silver is 93% pure silver and 7% other metals. Our sterling silver jewelry is not pure silver from the periodic table. It is a metal mixture. That's what an alloy is, a metal mixture, a homogeneous mixture. Another alloy is brass. Brass is really common. I feel like we've all heard of brass before. But if we were to look at the periodic table, there is no brass on the periodic table because it is an alloy. It's a homogeneous mixture made of 67% copper and 33% zinc. And here's what brass looks like. Seamless mixture. Homogeneous mixtures look the same throughout. It doesn't matter which little BB of brass we pick up, they look the same. I can't say, oh, get that one that has a little bit more copper in it, or get the one that has a little bit more zinc in it. It's the same. The components look the same throughout. If we're only going to remember one thing about a homogeneous mixture, this is it. It looks the same throughout. So that was homogeneous mixtures. Now let's talk about heterogeneous mixtures. Heterogeneous mixtures has components whose proportions vary. That means we can see all the different parts. The prefix hetero means different. So we have two examples of heterogeneous mixtures. We can see all of the different components. The proportion of those components vary. Here we have a mixture of elements. Copper and silicone. We can see all the bits of silicone. We can see all the bits of copper. And then I used a food example. Mixed nuts or trail mix. If we were eating trail mix and I said, oh, I love trail mix, but I hate the almonds. I can see the almonds and I can remove them. The components have proportions that vary. That's what makes them a heterogeneous mixture. So if we remember one specific thing about heterogeneous mixtures, it's that we can see all the different parts throughout the sample. So classifying matter, we've got this now, and we understand the two types of mixtures. If this video helped, press that like button. Don't forget to leave me a comment. Also, you must subscribe and turn on the notifications to get my next video. Hope that helped. Bye, y'all.